Hello, my name is Afzal Ali and I'm the Director of Technical Sales for Dublin Company. Today we will answer 4 simple questions. First, what's a slip ring? Second, why do we need a slip ring? Third, how does it function? And fourth, where does it go? So let's get started. What's a slip ring? What you see on the screen is exactly what I have in my hand. It's an electromechanical device. One component, the housing, is stationary and the other component rotates with the machine. The stationary component, the housing, has connectors. This is a connector for power. This is a connector for data. The rotating component has matching connectors, one for power and one for data. So this mechanism can receive data and power from a stationary source and transmit the data and power through the mechanism onto a rotating machine without any interruption. So the next question is, why do we need a slip ring? Here is a very simple illustration. Let's say you have a table that is rotating and you have a couple of components that are attached onto the table, and the table is rotating and we need to send power or signal or both to the rotating mechanism. If you had a simple cable, it'll snap and break. You will have a disaster in your hands. So what is the solution? The only solution is an electrical slip ring. The electrical slip ring accepts power from a stationary source or signal from a stationary source and is able to transmit to the rotating table without any interruption. Let's look at the guts of an electrical slip ring. This is the end view. If I was to take this and take the cover off, this is the end view without the cover. And this is the side view. So let's explore the components of the slip ring on the side view. Let's go clockwise. This is a connector for signal. Going clockwise, we have a set of conductor rings for signal. We have a set of conductor rings for power. Then we have an anti-rotation arm, and then we have the housing. So what's an anti-rotation arm? In this device, this is the anti-rotation arm. When this is rotating, this may try to drag and turn the housing as well. Since we don't want to rely on the cable or the wire, we can secure it externally and prevent the housing from rotation. Now, the end cover is off. And let's look at the rest of the components. We have the connector there. Moving clockwise, we have a lead wire signal. Further down, we have the brush that are in contact with the conductor rings. Further down, there's a brush block that holds the brush. Then we have a connector for power. Further clockwise, we have the lead wire for power. And then this is the rotor that is rotating. And we have brush that are physically in contact with the conductor rings, and above that we have a brush block for signal. What does all this mean? This is the electrical path through the slip ring. Here's the housing connector. From the housing connector through the lead wire to the brush block, which is stationary. Onto the brush block we have a set of brush. They are pin-like with a certain stiffness or spring rate that are physically in contact with the conductor rings. So we have the brush block, then the brush. From the brush, the flow path continues to the conductor rings that are rotating. From the conductor rings to the rotor lead wire. From the rotor lead wire to the rotor connector. So in this schematic, 1, 2, 3, 4 components are stationary, and then 5, 6, so 4, 5, 6, and 7 they are rotating, and this is the complete electrical path inside the slip ring. Circuit functions. There are 3 basic types of functions an electrical slip ring serves. One is deliver electrical power. That's obvious. Typical voltage could be from 110 volt to 680 volt. Current could be from 10 amps to 100 amps. Next, it's control signal. The control signal is typically low volt, and amp is also relatively low, less than 10. And then we have digital signal Ethernet, Profinet, voltage is typically very low, 4 to 5, and current is even lower, 10 to 20 milliamps. Let's look at the electrical requirements. One could have as low as 5 millivolts to 1000 plus volts. Current. Your current requirement may be as low as 10 milliamps to as high as 250 amps. Channels. You may have from 1 up to 100 or maybe even more than 100 channels. Here's a simple example. You have a 3-phase AC motor that needs 5 channels, 3 for lines A, B, and C, 1 for neutral and 1 for ground. On the other hand, for a 100 Mbps Ethernet, there are 4 channels that you need, 2 to transmit and 2 to receive. Transmission technology. Depending upon the speed, depending upon the duty, depending upon the volt and amp, we have different types of transmission technology that we employ. Here, the first one is carbon graphite. This is usually for high amps, high current, 30 amp to 250 amps. Then we have the monofilament, which looks like pins with a spring, with a stiffness, certain stiffness, typically less than 30 amps. And then we have polyfilament precious metal brush, and they are great for high data rates because they have very low contact resistance. Electrical connectivity. How would you like to have this device connected onto your machine? We can give you flying leads. It could be circular connectors, it could be modular connectors, it could be terminal blocks, it could be plug and play. You specify, we offer you a connection that meets your requirements. Now that's the electrical part. Let's talk about the mechanical part. Speed. How fast is your machine rotating? 1 RPM, 2 RPM, 5, 10, 15, 20, 500, 1000. We can accommodate a range of speed, but we need to know from you how fast your machine is turning. Next is life. In tens of millions of revolutions. What is the life expectancy? Are you happy with a 6-month life, or do you want a 6-year life? It all depends on the application, and it all depends on how frequent you can offer maintenance, you can service these equipment. Shock and vibration. What kind of shock and vibration will this slip ring be subject to? Envelope dimension. How much space are you giving us? And then mounting. How do you intend to mount it? Is it threaded connection? Is it a flanged connection? Are these standoffs? You specify the mechanical requirement of your machine, and we will design a slip ring to fit your requirements. Enclosure options. So here's my slip ring and here's my enclosure. The enclosure could be stainless steel, the enclosure could be anodized aluminum, the enclosure could be engineered plastic. Why do we offer all these different enclosure? It has to do with IP. IP stands for ingress protection. Our standard rating is 54. We can design up to 67. What does that mean? What that means is you specify the environment that the slip ring will be subject to. Dust, dirt, humidity, moisture, rain, splashes of water, or waves of water. And we will design a slip ring that can withstand the environment with the proper IP rating. Here's a list of design resources we have. I will not bore you with all the details. Suffice it to say, we have Autodesk Mechanical for 2D, Autodesk Inventor for 3D, we have ANSYS, we have all other design tools to design a slip ring for your specific application. Let's go to the test stand. What kind of testing capabilities do we have? Dielectric withstanding, we have circuit performance, we have life cycle testing. On top of that, every slip ring assembly cell is equipped with standard production testing procedure. This is general design limits. We can go 1 gigabits up to 6,000 volts, up to 250 amps, 100 plus channels. These are the various design limits, but then there's a little disclaimer here, and let me read that to you. Dublin can design to requirements exceeding the above limits. So even though we have a limit, depending upon your application, there is no limit. To handle all the communication needs, we have all these protocols we support: Ethernet, EtherCAT, Profinet, Profibus, CAN bus. Again, whatever your protocol might be, whatever your connector might be, we can have a matching appropriate connection on the slip ring. Analog signals. What are you trying to achieve? What are you trying to do? Thermocouples, strain gauges, vibration sensors, optical encoders. Specify, and we will design and offer a slip ring for your specific requirement. So now, where do these go? This is a very typical automotive assembly plant application for body panel welding. We have an electrical slip ring with 10 channels. In addition, we also have an air union to deliver air onto the rotating indexing table. Here is a wind turbine application. In the wind turbine, we've all seen wind turbine. These are large multi-million-dollar machines. They harness the power of the wind, convert that into rotational energy, which is then converted into electrical energy. So we all know that the wind velocity can vary, so there is a need to vary the pitch of the blades. How do you do that? You do that with an electrical slip ring to control the pitch or the angle of the blade attacking the wind. Here's a wafer processing for semiconductor industry. Here is another wafer processing. In fact, this guy is right here. Then we have a directional drilling application. We have a plastics machinery application. We have other applications, to list a few: wind, robotics, turntable, pick and place machines, winding machines, centrifuges, tooling machines, milling machines, handling systems, propulsion, and of course, packaging. So here's a couple of examples of problems we have solved with our engineering and our product. This particular packaging machinery company had a large filling machine. In conjunction with the slip ring, they wanted a large rotating union for high volume delivery. And we were able to consolidate a slip ring with a rotating union and offer a system solution to the machine builder. Here is another interesting application. This particular machine builder was using a slip ring with Mercury contacts. And we all know how friendly Mercury is to the environment, and we were able to replace that with environmentally friendly material that poses no hazard to the environment. Here's another example where a medical packaging machinery needed a very high power capacity slip ring, which was beyond the capacity of the slip ring supplier at the time. And we were able to offer a large slip ring with high power capacity, and this particular machine builder is absolutely satisfied, and we have solved their problem. And here's another example. And this particular one is, we call it through bore or around the shaft. So this particular slip ring does not fit at the end of the shaft. The machine builder had a need for the shaft to go through the slip ring, maybe for a drive mechanism or for whatever the reason might be, and we were able to design a slip ring. We call it through bore or around the shaft slip ring design. So we have come to the end. Thank you. Due to COVID, we were not able to make this presentation in person to you. However, the information is the same, and if I've said anything too fast, and if you have questions or an application, please make a note of this. It's a very simple email address, aali@dublin.com. Please send me an email, and you can be sure that I'll respond to it quickly. Thank you for your attention and time. Have a great day.